Good afternoon, folks. So how many of you are already working in AWS? Okay, let me do that the other way. How many of you are not yet working in AWS? Awesome. Hey, well then, you should know all about this, right? So I'm Sarah Novotny, and I work for a video game publishing company called Meteor Entertainment. Meteor Entertainment is brand new. We were venture-backed last October with Benchmark, Firstmark, and Rustic Canyon. And the whole idea behind Meteor Entertainment is to publish video games with an eye to transmedia. So as we move into a world where you have not just one screen, but two screens when you're watching television and fooling around on a computer or an iPad, or moving to a world where the world of a video game is not just the interactive space that you have yourself on a local computer, but one that you have with multiple players, or a whole world that exists out in the ether that you can participate in and has a whole history of lore. So we're telling the story across multiple types of media. So we have at this point a video game which launches December 12th, and we have a movie in production, we have a webcomic that is in production, we have the first part of a graphic novel that's being produced, and we're telling these stories, the story of Hawken, with as many media outlets as we possibly can. So this is the idea behind Meteor Entertainment. We didn't start with, the movie Star Wars and then find out that there are action figures and then find out that there's going to be a novel. We started with the story, and then from there said, we have this awesome game we want to make around this story, and then we also want to tell the rest of the story because the game only tells a portion of the story. So Hawken's going to be released on December 12th. That's, yes, in 14 days. And we are really, really excited about it. So why did we choose AWS? Why did we choose the cloud to do this? There were a bunch of reasons that led me to this. So I was brought on just about a year ago, and at that point, there was no infrastructure. There was no infrastructure staff, and there was a grand vision and a launch date. Which is a little bit cart before the horse, which this company seems to do a fair bit. But I went ahead and said, we've got just about a year. We're going to launch on December 12th. So I have a ticking time bomb, and I need to know how to get this game and potentially all these other pieces of media in front of the world, the entire world. We're self-publishing everywhere in the world except China. And I need to know how to get this story in front of the world in a way that makes sense to them and in a way that is easily accessible and very fast for them in less than a year. The nice thing about this was it was a green field. There was no infrastructure. I started with nothing, so I didn't have to convert anyone. I had to tell my story. I had to pitch the idea of infrastructure in the cloud, but I didn't actually have to convert anything. So the green field was one of the reasons that I chose AWS in the cloud. One of the other things that I did was I sat and I thought about what the business constraints were. What is it that is already decided by the business at this juncture? So I had a few decisions that had already been made. The game had been in production for almost a year when we got funded. We did that with the studio in LA that our venture capitalists folded into the VC funding. They had been working on this game for a year, and they had already chosen the Unreal server. So that was a business constraint. I knew I had to support Unreal. There were other business constraints. There was the timeline. It was going to be free to play. So free-to-play is an interesting model for a business model. And again, it's a business constraint that you sat and you started with. In free-to-play gaming, you don't expect that everyone's going to pay for it. It's kind of the opposite of a packaged goods model. In a packaged goods model, I know everyone will pay me $57 for this item. So my goal is to have, 1 million people do this, and I know exactly how much revenue I'm going to get. When you go on a free-to-play model, you actually don't know who's going to monetize. Different games monetize at different rates, but the industry standards are between 10 and 20% of monetizing users, or 10 to 20% of users monetize. So that means I need to support up to 90% of my users without expecting them to pay anything. So that was a business constraint I really had to pay attention to. Another business constraint here is we have to make sure that the game is not perceived as pay to win. So that's more of a game balance thing, not really my problem, but definitely a core business constraint for free-to-play. The game server, as I mentioned, was going to be Unreal. And Unreal has a couple of specific constraints around it. It runs on Windows. I wasn't very pleased about that. We didn't let that one really constrain us, to be fair. But the game had already been built and was already being worked on, and we knew that the game was going to not have a persistent game world. So all of my game servers were ephemeral. I knew that since 80 to 90% of my players wouldn't monetize, I needed this to be very low impact for personnel. So I couldn't have a lot of personnel that were working on building game servers, making game servers exist, bringing them up, bringing them down. I needed this to be incredibly automated. And I also knew, since we were working with a free-to-play model, that everything needed to be instrumented. We needed it to be incredibly instrumented because I had to be able to track how much every hour of gameplay costs for every user. So our target for gameplay per user right now, for costs for gameplay for a user, is about 4 cents per hour. Now, we're not there at the moment, but we're getting closer. So it had to be cheap. And we had to be able to support this free-to-play audience that was not going to necessarily monetize. Now, of course, on the business side, we've got people working very hard to make more people monetize at higher rates, all of that. But that's on the business side. What I can handle and what I can tune up is only on the tech side. So I knew that I had to have ephemeral, automated, very instrumented, and cheap game servers. So that constraint alone led me to the cloud. I knew on-demand resources were going to be key. I knew that everything that had to be automated meant that it was really going to have to be very API-driven. And even though we were venture-backed, I wanted to do my best to have zero capital investment to make this. One of the challenges with video game infrastructure is you build for who you think will be there, but you can't know who's going to come to the game until you've launched it. So if I build to have 100,000 people play and only 10,000 show up on the first day, I've still made that capital investment. Now, I may have 100,000 players in 6 weeks, or in 8 weeks, or in 10 weeks, but I still have this gap between what I have committed and what I have spent money on without actually reaching that audience initially. So we ended up choosing to start on the cloud from day one. And that led us to Amazon because, of course, they were leaps and bounds ahead of everyone else, even a year ago. So we actually make use of 13 different AWS services at this juncture. We have a fair number of them, and I don't know if I can match every one of those up there to names, but we have DynamoDB, we have S3, we have EC2, we have Route 53, we have SQS, we have SES, we have, let's see if I can get any of the others of these, Elastic IP, Elastic Load Balancer. Across our architecture, we make use of a lot of these services. And the key point there, of course, is through all of the automation. But what have we really learned over the last year? This is a big question for me, and I sat and I thought about it and I worked through it. The big thing for us, and it kind of fits with the whole mech theme for the first-person shooter mech game we're putting out, is you really, really, really need to make this highly automated. And the nice thing, we start talking about infrastructure as code. If you treat your infrastructure as code, you can make things very highly automated. You can minimize the amount of downtime you have because you're working through the very standard dev environment, staging environment, production environment. And you're working in a model that most software engineers are very familiar with, even as you're bringing your operations online. So I'm going to show you a couple of pieces of infrastructure we have. We have more than just these two that I've highlighted, but these were the two that had sort of the more interesting pieces that I wanted to talk about. So playhawken.com is a website which is going to become, as we launch the game, more and more integrated with the game. And we've found that there's some very fun little bits of the different services that AWS offer that can be really useful. One of the things in this, it's pretty straightforward, much of the infrastructure. So we have Route 53 and an ELB in front of the website. Really straightforward, basic architecture there. We have standard web server instances. They actually are backed by persistent storage in a way that our game servers aren't. But we have web servers that are backed by persistent storage. But we make use of EIP, which until about 6 weeks ago, I had no real use case that I could think of for EIP. But in the last 6 weeks, we came up with a really interesting one. We work with a lot of third-party vendors with both our website and our game servers. And one of the things that kept coming up recently was we need to whitelist your IPs. So if you're going to talk to our API, we need to whitelist this. And that's completely counter to how one interacts in the cloud. So my web servers are going to come and go, their IPs are going to change, but the ELB in front of it, the www.playhawken.com, isn't. But that you can't actually route traffic back out through an ELB. So what we ended up doing, we built a little fleet, a very small fleet of proxy instances that actually have EIPs attached to them. So if I lose one, great. I bring a new one up and I attach the EIP to it. But this allows us to whitelist the API connectors, allows us to whitelist the IPs that the APIs for our third-party services will get traffic from. So our website, it's one of those sort of simple things that until you look at it, until you think it through, it wasn't as obvious to me or to any of our engineering staff initially how we were going to handle this one. So I thought that was a fun use of the elastic IPs. We have a Dynamo backend for all of our user data, as well as our item store data and all of the inventory that we actually have for the game. And all of that is accessed from the website as well. So when you log into the website, you can see what is going on with your mechs, with your game, what your services are, what the profile is. The next very interesting chunk of architecture that I'm going to show you guys is the actual game server area. And this is at a pretty high level. We make use of S3 and CloudFront in order to distribute the game client. Pretty straightforward, standard CDN content. CloudFront actually is, S3 and CloudFront are where our additional CDNs pull their data from in order to be able to distribute across multiple CDNs and have, we actually have a CDN load balancer, Sidexis, in front of the CDNs in order to have the clients or the end gamers be able to pull the game client from edge areas. Pretty straightforward. The client, once you've downloaded it, connects to game servers. And these game servers are all completely ephemeral, as I mentioned before. So I build more when we need more. We took a page out of the Apache manual sort of here and said, we're going to keep in each region a number of min spare servers and then have a max spare servers. And once we have max spare servers hit, we start killing off servers. But in the min spare server case, we build them up as soon as we start going below the number of minimum spare servers. Our game servers, game client talks to the game servers. The game servers themselves are ephemeral. They have no stored data state, but they instead talked to game services, and those game services talk to the Dynamo backend for the most part. The Dynamo backend, as I said, has mostly profile data, item store data, and a whole bunch of game mechanic data in it as well. We have these game servers and these game services machines in multiple availability zones and multiple regions. So at this point, we're running out of 6 different regions across the world because one of those business constraints that I was talking about earlier was we needed to put a game server as close as possible to the end user as we could make it. So instead of building CapEx intensive custom data centers in multiple locations when I didn't know where our gamers would live, we instead said, great, EC2 has 8 or 9 regions now, and we can make use of those regions to get these game servers as close as possible to the end game or to the end game player. Our target is 50 milliseconds. That turns out to be not all that far from your average game player. So the game servers live in each of the regions as close as we can put them. The Dynamo backend at this point lives only in Virginia. We're hoping, and I'm going to point at Anthony again here. Anthony's my sales rep, my account manager, and we're working really hard to try to point out the need for multi-region replication for DynamoDB, and potentially even multi-master, multi-region DynamoDB replication. That's on my wish list for Christmas. I don't know if it is for anybody else. But we came away from all of this architecture as we were building it, and we started thinking about, when I was asked to give this talk, I started thinking about the big lessons that we'd learned. And one of the big ones is that you really need to think in terms of fleets. The world is no longer a space where you think in terms of servers. If you think in terms of servers, you have a very narrow view. So we think in terms of fleets. We think in terms of regions. We think in terms of collections of services. And when you have that full fleet of servers, you end up with a full product. Before that, you have a potential single point of failure, or multiple single points of failure. But we really build our world to think in terms of fleets. Okay. In thinking broadly and in terms of fleets, you find that you're no longer worrying about a single server. You're no longer worrying about whether or not this is working in that one place or on that one machine. If it doesn't appear to be working, kill it off. Build another one, deploy another one. We do this with lots and lots of automation tools. So behind our fleets and behind our management and scaling is a lot of Chef. We use hosted Chef, and we make use of lots of cookbooks to deploy our game server fleets and our game service fleets. We also make use of a product called Stratus, and that does allow us, in fact, to go to a single server and to log into that single server with good security and good access control if we need to. The goal is not to, but you still need to be able to mitigate against that instance when you actually need to go work on a single server. Ideally, we won't, but we still need to have a way to do that. The other thing that we found out is scaling up is really easy. Make more. Great. You've automated it. You've got your infrastructure as code all checked in. You can say, hey, I need 10 more of these. I need 100 more of these. I need 100 more in Singapore. I need more in other regions. That part is really straightforward, and we've actually gotten to a point occasionally where we have over-provisioned capacity. And over-provisioning capacity is great until you get the bill. But that's a lot closer to the old model of buying a bunch of servers and having your over-provisioned capacity waiting for you. So that has not been my super worry at the moment, or my biggest worry at the moment, is if we're over-provisioned, okay. Because as it turns out, scaling down turns out to be harder. So we figured out the scaling up thing pretty quick. That was easy. Scaling down is something you have to think through a whole lot more, at least in my world. So in my world, a game server will have roughly 30 people, or a maximum of roughly 30 people on it. But if 16 of them leave, that's great, but now I have a half-used server. So how do I figure out how to consolidate those users onto a game server that is also half full? So this is one of the problems that we have out there as something we've thought about, and we have some ideas how to clean up, but we haven't fixed yet. So we're sort of sitting in that middle space where we're not dedicated hardware provisioned with that big step cost, but we are over-provisioning right now in our game servers because tuning it down is harder. When we have empty game servers, it's easy to kill them off. The problem lies in the half-full game server. And that takes a little bit to figure out. So far, I've punted that to first quarter. We have some ideas. It'll be a good one. The key point in figuring this out is that your automation has to be application aware, and your application has to be automation aware. So you have to have the automation, so Chef has to understand what your game servers, or in my case, my game servers, are doing in order to know if there are users on it. I can't just go kill off that instance because I felt like it, or because I went ahead and did some sort of call into Chef's database to say, tell me machines in this region and I'll kill off half of them, because that would be a really, really poor user experience. But your application or your automation has to have a way to go into the application and understand how many users are on that server still. Can those users be consolidated onto another server? Is there a way to do that gracefully? Is the game about to end? Can we then throw them back out into the lobby to go be match made onto another server? Or do we have to wait until they finish this much longer game? So your automation has to be very aware of your application, but your application then also has to be aware of the automation that is happening underneath it. And this turns out to be a fairly complex problem. We ended up, as I said, punting this to first quarter, but we've got the big one that we're trying to figure out right now is to set up the instrumentation so that we know how many users are in which game servers and how much time is left in those games. Then the application has to understand that when that game, because it's, say, less than half full, when that game completes, we need to put those users back out to be match made into a new game that is potentially also underutilized. The problem that exists there is if I have two half-full servers and I kill them both off, then I need an empty one to consolidate those users into. It's an interesting problem, and you can end up with some fun race conditions there. Location was another big thing that we found interesting to work with. We have 7 regions up at this point, and we have game servers and game services in each of those locations. But we needed to make sure that those game services, in making calls back to DynamoDB in Virginia, because we have Dynamo that can only exist right now, non-replicated, out of one region. We had to have a way that our game services were very latency independent, whereas our game servers, we knew, were very latency dependent. So we made this a very loosely coupled architecture, and we made sure that the game services were not actually as dependent on the latency. We had to make sure that the game services could make a call, and it could take a little bit to get the answers back into the game services space. And that the game wasn't having trouble with that. So our game is fairly write-heavy and not so very read-heavy. We make roughly 1 API call to our game services every second per user, which actually means that we have a whole lot of API calls going all the way back to Virginia all the time. One of the other big things that we learned out of this is, and it seems like such a low-hanging fruit moment, APIs offer error codes. And this may really sound redundant or painfully dumb, but you need to check them. It seems so obvious, and yet we've run into problems again and again where people aren't checking the error codes from the APIs. Or they're checking the error codes, but assuming that any sort of 200 is the same. And you can't treat all 200s the same. It might be that the object wasn't there. I answered exactly what was correct. You got a yes, you got a true statement, but the object you went looking for wasn't there. Or it wasn't modified, or we went ahead and accepted it, or we want to, it's a best practice, and it seems like such an obvious one, but it was amazing the conversation we had when we found a couple of devs that were going, well, I got something in the 200 series, but it isn't working right. Well, no, they mean different things. So this is another thing that we found is something well worth just pointing out. It seems very obvious, but another thing that we have done with the very loosely coupled service-oriented architecture is planning for the failure. You don't know what server is going to disappear. You don't know what server might stay up forever. Be this because of your automation knocking a server out, or because a server was lost in through a hardware failure, or something may just be going wrong. One of the best tools that we've run into to test this, and I believe there's a whole session on it, is Chaos Monkey. Yeah, everybody's nodding. Yep. Let's just go ahead and set this monkey loose and have it go ahead and kill things at random. I don't know. Turns out you'll find those single points of failure you might not have known you had. It's a great tool. It is a great way for you to just to find those potential failure points. We've had some fun moments in realizing that there were single points of failure that we didn't know we had. Another really big thing that we've had problems with and had to figure out how to work around is synchronicity. So we do a lot of work with queues, and actually one of the best things for us about Amazon has been the ability to iterate across potential different options to solve our problems. So one of these options, for example, is DynamoDB was one of the choices we made, but we've also tested Reoc. We've also gone ahead and tried to figure out other ways to manage the data, including making use of flat files and queues for the different ways we sort data into the right buckets. But in building a loosely coupled distributed system, you need to understand that the data you sent as an application doesn't mean it's the same as the data you're going to retrieve yet, because that data may not have made it through its queues and landed into a database, or may not have made it through the queues and updated something that happened next. So figuring initially, while planning for your epic fail, while planning for location awareness and location agnosticism, because you might not be talking to something in the same region. You might not be talking to something in a different region. You can't know these things in a really loosely oriented architecture. The big one for us has been not necessarily knowing if the data that you think you just wrote as an application is going to be the same data you retrieve. And that was one that took us a fair bit to sort out and try to work through and understand how to loosely couple that. There is specific data that we know we need to be consistent and always consistent. So transaction data for purchasing, that is always consistent. It has to go into a database. It has to have transactions. We have to know when it fails. We have to know when it succeeds. But game vector data, hey, if I'm going to go ahead and shoot someone on the other side of the room, if the game server is knowing that, the statistics don't actually have to update immediately. That's something that would be great if it happens. When it happens, that's perfect. But occasionally, if it doesn't, that's okay too. So the statistics will update, just not necessarily at that moment, not immediately. But your application has to be aware of that and has to be okay with that. And so that's an interesting one for us to figure, it took us a while to figure out, is how to decouple that assumption that the data that was just written is the data that you would read. As we move to a replicated database backend, be it non-relational or relational, it's going to be even more the case, because with read replicas or read-write replicas, you have further latency as trying to get your data through, I don't know, a ring. If we move it all, it's sort of an old MySQL picture, is you'd have a ring of databases, and you'd have to figure out how to have your application be able to read from any one of those locations, but not necessarily have the same data that you would expect. So that was a big one. A big thing to pay attention to as you're building is thinking about that. We also spent a lot of time on culture, and this may be specific to gaming or it may not be. I came out of Big Web as a first point. Big Web has been doing this work for years. Whether or not on the cloud, virtualized or not, the idea has been very distributed almost from the beginning. It's not the same as sort of the enterprise monolithic stack or gaming, where you had a classic architecture of we build a game server infrastructure in this location because we think this is where the gamers are going to be, and then we build another one in this location because we think that's where the gamers will be. And that didn't always work out. Often it didn't work out. So I put my game servers in Germany. Well, as it turns out, I really actually monetize way better in North America. Or I put my game servers in North America and Poland, but Iceland is really where all my gamers are. So the legacy thinking, the challenges of the old school models in gaming when you're trying to talk about the cloud was one of the big things that we had to overcome. And we had to overcome a lot of packaged goods thinking when moving to the free-to-play model and an online game. And the cloud is all part of this. And these were big cultural challenges. I still run into challenges with some of the guys that have been developing for game studios for years, thinking for us that on 12/12 the work's done. But that really is just the beginning, because we have a full online architecture. We have a plan to be building new downloadable content. We're going to be running this as a multiplayer online game. The cultural changes in moving to the cloud and moving to an online system, which is a whole lot more like running a website than it is a packaged goods. So in gaming, as you talk about this stuff, there's a big, big cultural legacy that has to be overcome. And that's something that just has to be approached with patience. There's, excuse me, there's very little that we can do short of explaining the bigger picture, explaining why it fits, being able to talk at the business level as well as at the technological level, why this fits the needs that the game or the business has in order to move the model and the thinking to something that is more online, something that is not capital expenditure, something that is just on-demand resources. And for me, I lucked out. My earlier slide showed the buzzword compliance. I lucked out because our VCs were thrilled that I said, we really need to put this on the cloud. All of our business constraints suggest that on-demand resources would be perfect for this. They loved it. I lucked out. There are a lot of people who still think the cloud is more expensive, but you can actually do nice modeling for the business side. You can do nice modeling that shows that the capital expenditures and the overcapacity and I've hit the ceiling of my capacity, but now I have users that are pissed off because they can't play, and the elasticity of the cloud is a really relatively easy sell once they wrap their heads around it. But it does take some pictures, and it does take some education, as I say on here, and patience. There's another portion of this that we learned, which is don't overthink it. Don't make it overly complex just because you can. Distributed architecture is complex by nature. Service-oriented architecture is complex by nature. But find the simplest solutions. And find them and implement them until you find them broken. We've built, I think, 3 different queuing systems now, and each time they've been simplifying it, because the first one was a whole AMQP architecture and a whole big setup of queues and listeners, and these things did this and this other thing, and it turned out our business analysts didn't want the data the way we were pulling it out and the way we were building it. They wanted a quick little SQL database to read against. And so we had over-engineered for that. So we built the second version. Great, the second version was 0MQ. Fantastic, it'll be a little bit easier. We'll do it a little bit simpler. We'll not do it quite so complex. We'll not make so many queues. We'll not make listeners for everything. Well, the version 2, this is another great reason for the cloud. Version 2, still too complex. Right now we have in place Amazon's SQS, and a little bit of listeners that are set up right now for us. But most of our data for the vector data, so the data like I shot someone, or I ran this way, or I did something to the environment, most of that data right now is going into flat files. And S3 is a whole lot cheaper than anything else that I can use in that architecture. And it's the simplest, most brain-dead architecture. We haven't had any problems with it since. Our business users are fantastically happy with it. We can do MapReduce jobs against the flat files. Simplicity is really one of the key points in building a good, sustainable architecture. We found, as far as Amazon and web services, what we've been able to do, because we have the different services that are available to us, plus we have compute, and we have the simplicity of, we can do it ourselves on EC2 if we want. We can run our own queuing system. We can build all of that, or we can use the simple service. By being able to do that, we've been able to iterate through options and find the right level of complexity, sort of the not too hot, the not too cold version of this, trying to figure out what the right variant is and use, of course, as I hope most people here do, agile methodology, if it's right for you, to find what we're looking for, have it looked at by the business users, make sure that we're giving them what they need, bring it back, do it again if it's not what they need. But basically, make the ability to launch things on demand, not spend a lot of money on core infrastructures up front, and change things rapidly as is just so much easier with on-demand resources. So